In this work, we introduce a method for planning over roadmaps we call selective densification. We address the robotics problem of planning a path from a start configuration to a goal configuration that avoids known obstacles. We build on the approach of using a roadmap. A roadmap is a graph where nodes correspond to robot configurations. The planning problem is then reduced to finding a path in this graph. Here we show a 2D illustration. A challenge is knowing how densely to space nodes in the graph. Too sparse, and the graph might not have a solution. Too dense, and the search becomes too expensive. Our approach is to build a layered graph that captures multiple densities. The top layer is a very sparse roadmap. The next layer contains a denser roadmap. It contains all the configurations from the previous layer and adds additional configurations. We connect the nodes from different layers, but at the same configuration, with zero-cost vertical edges. We continue this process, creating denser and denser layers. Remember, this graph represents a 2D roadmap, so the vertical edges here do not correspond to any robot motion. Obstacles block the same configurations in all layers. We find a path using a heuristic search, checking edge validity online. Our heuristic has an inflation factor that gets larger as layer depth increases. This guides the search to expand nodes that are both close to the goal and on the sparse layers that are fast to search. Notice how the search uses dense layers to get through narrow passages and returns to sparse layers in open space. For this problem, the nodes on the densest layers were never expanded. By prioritizing the sparse layers, we expand very few nodes and have to check very few edges. We see our path is rather jagged and longer than necessary. We solve this using shortcut smoothing. We observe smoothing finds shorter paths than searching on denser layers. We apply selective densification to a 7-jointed robot arm. Here, a node in the graph represents a 7-dimensional configuration. We check collisions by voxelizing the robot and obstacles. Here we show all the edges checked during a search. After smoothing, we find a short path to the goal. Finally, we show selective densification planning into a tight space. In this work, we introduce the layered graph and the selective densification heuristic for planning. In the paper, we discuss optimizations and other benefits of our method, present proofs, and show a slight variation on bidirectional search that gives better performance in our context.